Brett here, and today we're going to talk about our Rife sensor options for transmissions. So if you run a Turbo 400 or Powerglide transmission, or even a 700 R4, basically any older transmission without modern electronics, a lot of people don't think that you need to have sensors on these transmissions. They leave the trans shop, they're dynoed at trans shop, and then they're good to go. You're missing out on a lot of key data and a lot of diagnostic equipment that can be available for you to build while you're racing your car. Basically, we have pressure sensor options available to measure 2 pressures or 3 pressures. So on our 3 pressure unit, this would be used for like a lockup style transmission, and that's what we have on the bench here. We'll have converter charge pressure, transmission line pressure, and then lockup clutch pressure. On our 2 sensor option, you would have line pressure and converter charge pressure. Now you can also use our screw-in style pressure sensors. You'll see people will just direct them directly, onto the ports around the transmission. What's nice about the block is, as you already know, it puts all the sensors in one location. They're protected against vibrations, and you only have one wire going to that block to lead each sensor. And then from each one, you'll just run a hose to the dedicated port to pick up that pressure, and then you're good to go. Transmission pressure is often overlooked or not recorded, but is very valuable in tuning your car, your transmission, and knowing if you have something going wrong. Converter charge pressure is probably the most important out of all of them. To know what it is at idle, to know what it is on the trans brake, see it in spool on the gear changes, and be able to monitor the life of the transmission and help dial your converter in with your converter company. Every trans builder, every engine combination is going to require a little bit different of a converter charge pressure. You'll have to consult with your trans builder on what they have it set for. If they're jetted internally, some people will run an external regulator to adjust the pressure. We have dump valves that's going to manipulate the pressure. So all this converter charge pressure manipulation, you need to know what's happening. You need to know, did my dump valve turn on? Did my dump valve turn off? How long did it take the converter to recover from the dump valve activation to know when the converter is full again, to leave the starting line, or if you're using the dump valve down track? All this information is going to only be read from this sensor. Without this sensor, you're not going to know any of that. You're going to be guessing or have a mechanical gauge with a video camera trying to see how it is going down track. The transmission line pressure is something more just as a diagnostic tool. So this is going to be set based on if you have a stock case or an aftermarket case 400. The stock case is limited on pressure as the case can explode. When you have an aftermarket case, the pressure is usually bumped up 225, 250 from trans builders. That's pretty standard throughout the industry. This is a good thing to monitor on every pass, basically to know if you have any internal leaks to the trans or if your pump is going bad. So basically that pressure is going to stay pretty constant. When you hit the trans brake button, it's going to dip for a second, then it's going to come back. Gear changes, you may see a little dip just as the pump recovers, but then that's going to stay flat. So if you have a slip in high gear and you're like, man, what's going on? You look at your trans pressure, you see you're losing trans pressure in high gear. You know you have an internal leak on that direct clutch or on that circuit. So you can identify this problem before you smoke your trans, kind of pull it out, take a look at it, have your trans builder look at it. And again, it's just diagnostic tool available to you to get your library of information. So one of the things with sensors in general with everyone's car is car to car, everything's going to be a little different. Your pressures, your temperatures, everyone's going to just kind of be how it is when it leaves that trans shop. 10, 20 PSI, it may be a little different. So what you want to do is kind of, you have a go, no-go status, right? We know if it's here, it's bad, or here, it's bad, but in this range that we're okay. And you're going to monitor that basically every pass or the life cycle of your car. Just so, you look at your data log, okay, check, trans pressure is good, this is good, we have a consistency over the board. So that way when you do have an issue, if you go back to those logs, you can say, oh, well, it's been X forever and now it's Y, so we need to investigate to see what the problem is. On a lockup transmission, it's important to measure the lockup pressure, again, for diagnostic and tuning. These are fluid circuits in the transmission. So we click an electric valve, closes the valve, and then fluid pressure is then directed to the circuit to fill whichever gear, piston or clutch piston is activated in there. All of this stuff takes time, and all of this stuff has a very small amount of internal leak because a lot of times it's just shaft on a bushing and it's a fluid seal. So when you activate your lockup solenoid, it may take 1/10 of a second or 25 milliseconds before that clutch actually engages. You'll see that in your pressure. You'll see your duty cycle go to your solenoid. You'll see no action from the pressure sensor. Then your lockup clutch will engage and you'll see the pressure there. Now, if you have a leak on an O-ring or in the circuit, you can see that this pressure isn't what it's supposed to be, so you can help diagnose why your lockup clutch isn't working and help get your on-time set right with the offset of pressure it takes. So, if you turn it on at 1 second, the lockup clutch may not be engaged until 1.2 seconds. You can monitor your pressure and your time and do the math and kind of move that around during your run. Another big benefit to the blocks is the M5 connector for temperature sensor input. So again, you have one electrical connector coming from your car harness, plug in your entire transmission. So if you have to service your trans, basically one connector and then your trans brake dump valve connector, and then the trans can come out. All this will stay on the unit. The M5 connector goes around to a temp sensor that's in the pan, and then it's going to come out of your car loom right here. And then the 2 pressure and the 3 pressure sensor have this temp sensor input, so it's nice, keeps your transmission modular. If you have a spare trans, you could set it up just like this too. So if you need to change it at the track, it's just one plug and it's in and out. You're not messing around with hoses and everything. Now, as far as your pickup points on the transmission, they're all basically the same. So for converter charge pressure, you're going to get it on the out circuit of your transmission. So these are the trans cooler lines. This trans is set up. This is the out, and then the in goes back to the pan. Some will have the in here at the trans. So they're all a little different on that, but out is typically always out. It's going to go to your cooler circuit, or if you don't have a cooler circuit, it's going to go to your dump valve. You're going to use like a T fitting here, a gauge port, and then that's where our hose is going to run from this out to our converter sensor. This is going to tell you the exhaust out pressure, the charge pressure of your converter circuit. This is the standard pressure that everyone uses and utilizes on that. I'm going to spin the table around and we'll look at the other side of the transmission. On the Turbo 400 stock case or aftermarket case, our line pressure, our transmission line pressure, so this is direct pump pressure feeding everything in the transmission. It's going to be right into the side of the case here. So we're just going to go ahead and take the plug out, put a fitting into that, and run our hose around transmission line. If you have a lockup transmission, you're going to have a plug right here. It's going to have this fitting. So there's a hose inside the valve body to the solenoid that runs up here that feeds this for your pressure reading. If you have a 2-stage lockup transmission, you'll have what looks like a dump valve on the side here, and there'll be a hose coming from here to that. That guy will have a port on the back of him where you can pick up this lockup pressure. This circuit will only have pressure when the lockup solenoid is engaged, activated, and that circuit's filling with pressure. So that way you'll know that you have pressure getting to your clutch on or off. One other important part that we offer that you can see here now is our shift position sensor. So this is just our 5-volt potentiometer. It's essentially the same as a shock sensor. It's going to be 0 volts closed, 5 volts open. What we're going to do here is we have a bracket that bolts to the side. This is an operator shifter bracket. Your shifter cable goes through there. This bolts directly onto that. And then there's a hole in our linkage that this bolts to here. You're going to calibrate this custom calibration in the car with each gear position. You're going to assign a voltage to that. What that's going to do is allow your ECU to know when your transmission's physically in first gear, second gear, neutral, reverse, and etc. This can be used for a couple things. First, if you have a gear display on your dash, that way you verify you're in gear, this is going to go to that. And then secondly, this is good data for when you're going down the track. Maybe the car felt like it didn't shift one pass, and you kind of be like, I don't know, did I shift it? It shifts automatically. Did the shifter shift it? Well, being down here at the linkage, you're going to have that readout in your ECU. You're going to know exactly that this linkage moved to the position that it needed to be in, so you can figure out where your problem is. And I actually have a good data log example we'll show you here in a second on when this came into play. All right, so here's a data log of transmission converter pressure and transmission line pressure during a drag racing run. So during spool up and then going down the track. Maybe you haven't seen what one of these looks like for pressure, so that's why we're going to give you this example here. Basically, here's our run here. So this is our engine speed. It's basically at idle. This is spooling. We get on the trans brake. It's off flat on the 2-step here, and then it's our run. So right here, as we're idling on the starting line, our charge pressure is 30 psi, just sitting at idle, what it's going to go. Once we activate the trans brake button, we can see our internal and external dump open. Pressure dips down 10, 11, 17 psi. Car now, we floored it, we're starting to spool the car. As it's coming up on boost, now on this particular application, we're shutting the internal dump valve. Now, internal dump valve is shut to let the converter fill back up with pressure. As we're approaching the chip at a certain manifold pressure, now our external dump closes, so now all the dumps are closed and we're on a natural internal circuit of the torque converter. Now we can see our pressure now start to climb. The converter fills, stabilizes here around 100 psi on the trans brake. Then right here we let go of the button. When we let go of the button, the stator goes into spool mode in the converter. When that happens, it's going to create a lot of exhaust pressure on that circuit. Here we can see it goes to 150 psi. Some transmissions you can see this go as high as 250 psi during stator spool. Again, it's going to be different every time, but once you get that data log, that library built of tune-ups in your car, you'll know what it's supposed to be looking at. Another good tool that this is, another good use that this is a good tool for is monitoring your cooler. Every transmission has a certain amount of flow rate on converter charge, and I've ran into more times in the past that the transmission cooler core itself was too restrictive and had too much of a pressure drop across the core, and we see this pressure go up to as high as 350 psi. Bypass the cooler, and then it's back down. So this is a good test. If you get this on here, you feel like you have really high line pressure, transbuilders say, hey, it shouldn't be that high. Try bypassing your cooler and seeing how that goes. We've had to, as drastic as to split coolers and run 2 on certain systems with some transmission builders have a really high volume of converter pressure, and you'll have to actually split that, use dash 8 lines, have 2 coolers to split the circuit to have less pressure drop. So it's a good thing to keep an eye on. You can see the life, or if you think your cooler is getting clogged, all of these pressures will be high. Okay, so we're back to the run. Stator's in stall mode. It's caught up now. You can see in our engine speed, the stator now is at the stall speed and is starting to accelerate the car. The engine speed's matching wheel speed. We're climbing up through. Converter pressure is going down to normal. Gear change happens. You'll see the converter kind of dip into stall mode again on the gear change as it falls to the stall point, run through the gear, and then it happens again on the next gear change. So this is a very normal looking run. When we get back to the dump section, now if you're using the dumps to manipulate your starting line pressures, now you'll be able to see how far out after starting line it takes for the converter to recover, if you have enough charge pressure in the converter, or if you need to start backing the dumps up to allow more power to be applied to the racetrack. We can see our transmission line pressure, in gear idling, staying down here. Then as the engine speed increases to normal, we just kind of hold 220 psi straight across the board here, which is totally normal. Like I said, you'll just kind of see that. And when you open your data log your next run, if you see something weird, you go, oh man, I need to take a look at that and investigate further on what's going on. Now we have a data log here, and this CVT style of transmission that you're seeing here is actually a gear change problem that we had. This is actually from Doug's car on sick week. We had to open the dump valves through the first second of the run because the track conditions were really bad. So we just did that to ease the amount of torque being applied to the tires rather than lowering the manifold pressure, and it worked really well. But what we ran into was the converter took a long time to fill, so that we didn't get a big drop on the gear change. The converter couldn't recover in time. And then with this car being set on auto shift at 8,300, you can see our gear position here. We're in first gear. It commands second gear, right? RPM didn't really drop because the converter didn't recover. And then within a half a second, we're still at that same engine speed. So then the ECU commanded third gear. So now it's in third gear way too early in the run. It's just basically blowing through third gear because it's in third gear after 1 second of the run until the torque converter locked up and then pulled it down. We were able to fix this real easy. We put in a shift lockout timer, so the ECU is not allowed to shift second gear until X amount of time on the racetrack and engine speed, and then third gear until X amount of time and then engine speed. But without this gear position indicator, we were kind of scratching our heads. Doug came back and was like, man, I think second gear's burned out of the trans. It just slipped the whole way down the track. We saw this and we're like, yeah, like we had first gear, there was no third gear, but we can see here really clear that second gear's fine in the transmission. It just shifted to third right away and was trying to run down the track. Okay, so that was an overview on the products that we have for transmission monitoring. So we have gear position, which I believe is very important, and then our pressure readings and our temperature reading. We have, again, available for 2 pressure, 3 pressure. We have multiple different size temperature sensors depending on what your pan fitting is, 3/8, quarter inch, and an 1/8 inch NPT, gear position sensors, everything you need to properly monitor, race, and diagnose your transmission. If you guys have any questions or suggestions for any other tech tip videos or data log reviews, please leave it in the comments below and we'll try to do them.